Hello everyone, welcome to the beginning of week 3. It's actually going to be a pretty short day today. We're kind of ahead of schedule actually. We're super ahead of schedule. Uh, we finished dictionaries last week on Thursday. Wednesday I mean. Today was going to be more on dictionaries. I think we're just going to give some hints to the next programming project. There is going to be, we are going to end super short today, so I'm going to make up by recording an optional material. I'm going to record this optional material in a separate video because it's kind of a separate topic. And if folks are wondering what that optional recording will be, it's pretty much going to be talking about Python in practice. For folks who are trying to get a job as like a software engineer, or maybe you're going to go into a company and write tools for them, it's likely that you might see Python in a different style. So yeah, stay tuned for the next recording. It's going to be optional, and it's going to address Python in a different style, not a Jupyter Notebook. Okay, but the whole goal of today is really more on dictionaries. If anything, we're going to jump into hints on this next programming project. It's called weather. There are lessons in lab, 8. We'll do this one on Wednesday. I think this is on strings and printing. So let me double check the Jupyter real quick. Okay, let's see. Lessons. Yeah. Lesson 8 is going to be on Wednesday, 2 more days from now. And then same with the lab. Yeah, we'll cover this next time. So I'm just going to quit this. This is not related to dictionaries. Okay, let's take a sneak peek into this project. I'm going to go ahead and download it from Canvas. Okay, Canvas. Right here, project week 3. Okay, let me go ahead and download it to my computer. Hold up, it's not downloading. Oh, maybe I moved it. Let's see. Is this reproducible on other people's end? It's locked? Okay. Let me unlock it. Thank you for checking. Give me 1 second. I'm going to do this off screen. Okay. Okay, and yeah, for folks on the recording, it's going to work by the time you see this. So just go ahead and fast forward like 30 seconds. Okay, let's see. Yeah. Okay, let me test it. Okay, I think I unlocked it now. Let me download it again. Download. Okay, perfect. I hope this works for folks. So once you have it downloaded, let me upload it to the Jupyter Lab. I'm going to make a dedicated folder for this. Let's see, I'm going to call it week 3, a folder. Week 3, I'll call it weather. You can call it whatever you want. And I'm going to go ahead and drag this notebook into here. Okay. Cool. There it is. There is our weather notebook. Okay. Let me give a quick context on this notebook. In the previous material, we were hard coding data. Hard coding data means to dump data straight into the source code. For example, over in the labs, all right, let me go to one of the previous labs. Okay, our most recent lab was using dictionaries. This is hard-coded data right here. Right, we created a dictionary called courses, and it contains 4 key value pairs. This is hard-coded because it's not general. Right, we dumped data out into the source code. In the real world, it's more appropriate to gather data from elsewhere, right? So this wouldn't really be here. There would probably, you can kind of imagine that we would say courses is equal to an empty thing, right? Imagine we initialize it to empty, and then just kind of imagine we downloaded it from the Cabrillo server, right? So just kind of imagine there was like courses is, instead of courses equal to empty, I'll say courses is equal to like Cabrillo dot download data. Right, so imagine something like this, that this doesn't exist, but hopefully people kind of see that this is a little more general. Right? We're downloading the data, and you can maybe assume that it's going to be formatted in some sort of dictionary like this. So this is not hard coding. So yeah, lately we've been hard coding, right? We've been dumping data out into the source code, right, including, what else? Including the previous, right? The previous one on lists. This was also hard coding. This is, once again, just for demonstration purposes, right? We hard coded a list of 5 items here. Right? Typically, you would get data from elsewhere, right? Maybe from input, from some other thing, right? Maybe if you're working with hardware, right, the input would come from hardware, or maybe you're working with user input. So, you know what? I'm actually going to talk about that in the next optional recording. The next optional recording will be Python in a different style, and it's not going to be hard coding a lot. Okay, the reason why I mentioned hard coding is because this current notebook is one of the first notebooks we'll actually download data. We're going to be using a API. I set up an API, which stands for Application Programmable Interface. There is a website called Open Weather Map. This website provides an API. Right? An API is like a tool that lets programmers access the company's data. So this website provides people with weather data. To be specific, the API here, the programmable interface, we have access to this thing called one call, and it gives us access to forecasts, right? Like weather in the future. It gives us a lot of other things too. Like let me look at the documentation. Okay, so let me just zoom in a bit. Okay, I'm not going to go through this documentation. It is a little dense to read. The notebook will simplify it for us. But all you need to know is the notebook is already set up to download data from this source. Okay. The whole point of this notebook is to access that data and print it out. That's literally it. The data will be downloaded and formatted in a dictionary right here. This is actually already going to be set up for you. Now, once again, a dictionary contains key value pairs. So you can imagine that later on we're going to see a cell that will download into this certain format. So let me go down real quick. And once again, the whole goal of this assignment is to access the data and print out several lines. Right, so print out several lines. Your lines may vary depending on the current conditions that you press play. Right, so currently it says it's raining, but it's not. This is just an example of what it should look like. Okay, but let's go ahead and talk about the data real quick. I'll let folks read these requirements later. Okay, the first code cell here, you really don't have to worry about it too much. Just kind of treat it like a black box. Right? Just assume that it's doing what you want. This black box is downloading, is setting up tools for us to download data. Right? If you want to read ahead, this is called a function. This whole cell defines one function called getWeather. And this function will return a dictionary for us. Right? It's basically going to access the website, and then it's going to go ahead and download the data and format it into a dictionary. So it's doing a lot of the hard work for us. Right? Once again, just treat this like a black box. Here, let's see if folks are wondering what I mean by black box. I'm gonna look at the picture real quick. Black box analogy. So let's see. Let me look at the Wikipedia actually. Okay, let's see. So this is like a scientific concept, right? A black box is a system that can be viewed as inputs and outputs, right, without any knowledge of its internal workings. So basically I'm saying that you don't have to care what's inside of it. Just kind of understand the inputs and outputs. Right? In this case, we really have to care about the output from the function. Okay, so I hope that makes sense, right? The whole black box is right here. All you really need to know is how to use it. So let me just run this cell real quick. Okay, so I just ran it. It actually doesn't do anything. Well, it doesn't output anything. Right? There's nothing at the bottom of the cell. All it did was load a function to the kernel. Right? The kernel is the Python process. So the Python notebook now has access to this black box, right? Meaning we can use it to download data. Okay, so once again, all we did was load in a function. Right? We didn't call the function yet. Okay, so the next cell down here shows an example on downloading the data. This first line right here, this is creating a variable called weather. And then it's setting it equal to the result of this function. Okay, this function, we just loaded it in. Right? This is the function above. Right? So this line right here is saying, use that function and store its result into this weather variable. And this is actually going to be a weather dictionary. Okay, so let's go ahead and run it. Okay, so I'll go ahead and press play. Okay, so let's kind of step through what happened. Right? So it downloaded data from the internet, stored it into a dictionary called weather, and then these next two lines are just accessing elements within it. Right here, let's kind of navigate this dictionary a bit. So I'm actually just going to create another cell just to have like a playground. So let me press plus here. There we go. I inserted another cell. This is going to help us kind of navigate around the dictionary and see what's in it. Okay, so let me look at what weather is. Right, Jupyter Notebook will show us the value of the last expression. Right, this is the last expression. So let me press play here. Okay, there it is. I pressed play. So the value of this, it's a dictionary of key value pairs. Right, the first key value pair here is title and clear. Right, so this is one element, and the next one is an icon. Now, you don't have to worry about what the icon is until the next assignment. There's another one here called temperature. Right, the key is here, and then the value is a float. Right, a float is a decimal. Okay, temperature. So it says it's 293 degrees right now. It's actually in Kelvin, which is a different metric. If you were to convert this to Fahrenheit, it would make a little more sense. Right here, let me just convert it real quick using an online calculator. So let me go Kelvin to Fahrenheit. Okay, Kelvin to Fahrenheit. So yeah, it's 69 degrees right now. And let me just double check my weather app on my phone. Okay, my weather app on the phone is actually saying it's 67 degrees. But that's probably because the data is in a different location. But basically, we download it from a certain longitude and latitude. Right? So it's an approximate. Okay, cool. So this is our data, right? Let me just visualize this real quick, or prove that it is a dictionary. So I'll put it in the type function. Okay, type. And then let me just run this. And yeah, there it is. Just prove that is a dictionary. Okay. It is a fancy data structure though. If you saw last week's recording where we're here, you might have seen something called a data structure. In this case, we see that the key value pair daily, its value is actually a data structure. Right? It's a data structure. In particular, it's a list. So let's navigate this dictionary a bit, real quick. So here, let's actually just access the first this key value pair title. Right. So if you remember, we can dictionaries are indexed by the key name. Right. In this case, the key name is title as a string. This is going to access the clear value. Right. So this evaluates to clear. Right. And here, let me just go back to weather. Right. If we go to temperature, right. So weather temperature, this will represent 293. Right. Once again, this is in Kelvin. Okay. I'm just going to delete and keep trying some stuff. Right. You can try this out later. Let's see. Let me skip to humidity. Okay. So humidity. 79.0. This is a float, by the way. It's not a string, meaning we can do math on it. Right, so you will need to do math on certain stuff, like you do need to do math on the temperature and the highs and lows. Right? But basically, part of the assignment is to access this value and print it out in Fahrenheit. Right? And since this is in a number, you'll be able to do arithmetic on it. Okay. Let's go ahead and access one more thing, right? Access daily. Okay, so we're diving into a dictionary and actually accessing another data structure. So let me press play here, right? We see that the value of this is a whole list. And just to prove it, I'll put it in a type right here. So type, and boom, it's a list, right? Just to prove it, meaning we can do list operations on it. Right, like one list operation we can do is access elements inside of it. Right, how do we access the first element in the list? Now, if you remember from last week, lists are indexed by numbers. Right, 0, 1, 2, 3. So if you were to access the first element, this is 0. Right, so 0 right there. You can access clouds, and then all the way to the very end. Let me see what the end is. Let me just count this real quick. 0, 1, 2, 3, 4, 5, 6, 7. So it looks like it's giving us all the way to 7, and then 8 will not work, right? Because that's outside of the list range. Okay. Yeah, so this API is providing us with it's providing us with a lot of things. It's providing us with, in particular, I can scroll up and have a more description. All right, so scroll up. This is the format of the dictionary. Right? The data that we downloaded is the current weather condition. Right? The icon, you don't have to worry about this yet. The current temperature, highs and lows, and humidity and percentage, and then finally the list of strings. Oh, this is a typo right here. My bad. So the typo here is, it says the key's name is forecast, but we saw in the dictionary that the key's name is actually daily. So if you don't mind helping me fix that typo, but basically the key's name here should be daily instead. So I'm just gonna I just double clicked into this text cell. Right, I'm just gonna change daily. Change it to daily. Oh, it looks like we can't change it. So I'm trying to type, but it's not letting me type. That's probably because it's read only. This cell is read only for security reasons. And yeah, you can actually unlock it if you want. So let me just go ahead and unlock it. Let me see where it's at. Here. Oh, it's here. So I'll just click on top right. And then common tools. read only. Okay, I'm just going to change this to editable. This way I can unlock the cell. Okay, it's editable. Now I can change it to daily. Okay, you don't have to do this. This is just, I was supposed to do this. Okay, there we go. I just fixed the typo. Okay, it shows daily now. Okay, hope that kind of makes sense what we did. Right? All we did was load in a function that was already built for us. Oh, hold on. What happened to my cells? Here, let me refresh. I think my browser froze. Let me save it and refresh it. Okay. Okay, cool. I just had to refresh. All we did so far was load in a pre-built function, and then we used that function, right? We called that function. This is actually, we'll see this in a couple weeks. To formalize things, this is invoking the get weather function. It's invoking the get weather function, and then storing, let me put on a new line, and then it stores the return value into weather, right? Weather becomes a dictionary because that's the return value. So this terminology might not make sense yet. We'll cover functions in a couple weeks, right? But just to visualize things, just think of get weather as a black box, right? Here, let me put things side by side real quick. So let me put it side by side. Boom. Okay. So all you gotta see is, so you see these numbers right here. So these numbers, 36.9 and negative 121.9, that represents the input to the black box. Right? In this case, it's the latitude and longitude. So we put the latitude and longitude into the black box. Right? The black box here is called get weather. And then the black box will output. It's going to give us a return value, which ends up being the dictionary. Right? Weather, we saw that the return value is this dictionary here. Okay, cool. So yeah, give it some time to navigate the dictionary and kind of play around with it. But the whole point of the assignment is to access elements and print it. So our final printout should look something like this. Right? The first line should print out the current conditions, and then this is a hard-coded value right here, rain. Right? So please don't hard-code rain into it. You're going to want to get the data from the dictionary instead. So here, I'll help folks get started. Let me help folks get started with the first couple lines. Okay, let's get current conditions done first. Okay, so over here in the solution cell, let me put my name here. All right, let me set up that first line. So it was print. Hold up, I already forgot what it needed to print. Current conditions, and then colon. Okay, so we need to print current conditions, and then colon. Okay, let me press play here, just to make sure there's no typos. Press play. Okay, cool. We got current condition. And now we just need to get the value to the right of it. Right? Well, once again, please don't hard code rain into here. Right? This is inappropriate because you're going to want to be able to run this in the future and then see the values kind of change. And so please don't hard code rain into this. We instead want to get the certain value. Right? So how do we get that value? Current conditions. Well, I mean, you could look at this formatting. Right? We could get the current condition from the key title. Right? This returns us the current weather condition. And we saw that over here too. We saw that in this actual weather dictionary. Right? The key is title, and which represents the current condition. Right? Current condition is clear. So once again, to access that, right, it's title, right? Title, meaning that this print statement would have to involve title, right? Weather and then title. Okay, once again, we're putting multiple things inside of the print statement. So let me press play on this. So press play. There we go. Right, current condition is clear. Okay, hopefully people are cool with this so far. So we just got the first line done. Let me change this back. Okay, let's look at the next line. This is going to require a conversion. Okay, the next line wants us to print out the temperature. And the assignment does ask to convert it to Fahrenheit. And yeah, there's a formula down here. We'll look at it in a bit. But let's set things up first. Let's set up this second line, temperature. Okay, so temperature, go down here. Let's do another print statement. Print, and then temperature, colon. Okay, there we go. Got temperature, and now we just need to access the value. Right, so the value right here, right? We can see it in this above cell. And we just need to access the key temperature. And that'll give us this float. Right? A float is a decimal. So let me put in temperature real quick. So temperature, right? It's weather and then temperature. Okay, let me just press play real quick. Okay, there it is. Right, we got this right here, 293.74. If anything, we do need to convert it to Fahrenheit. And yeah, let me just look at the conversion real quick. So let me look at the conversion over here. Rapid tables. Okay, the conversion is Fahrenheit is equal to Kelvin times this fraction, and then subtracting this offset right here. So yeah, let me implement that. Python does use the asterisk as a multiplication, so careful not to use an actual x. You're going to want to use the asterisk, which is the symbol above your 8. Okay, so let me use this formula. Okay, so we pretty much want to multiply this by a fraction, right? We can do math inside of a print statement, by the way, right? Because these are numbers, so we can just multiply this by the fraction. Right? The fraction was 9 divided by 5, and then we just needed to subtract that offset. Right? What was the offset again? It was 459.6, 459.67. I'm gonna paste that into here. There we go. Cool. Okay, let me test this. So let me press play, and yeah, there we go. Right, it printed this long decimal. Okay, so this is in Fahrenheit. You don't have to worry about this long decimal. But basically, there's some imprecision in computer science. Decimals can't be perfectly represented. They're actually an approximate. So it's very accurate until you get to the lower significant figures. But yeah, you don't have to worry about it too much. If you did want to round it to 2 decimal places, that's possible. There's so many different ways you can round this to 2 decimals. I'll let folks look into that if you want. Or you could ask in the discussions, and I could just go over a few different examples. Okay, if anything, we should probably have the unit, right? Like if we look at the expected print statement, we're expecting the unit here, right? Like a F, right? This is saying Fahrenheit. So let me go ahead and add to that print statement, Fahrenheit. Okay, so I'm just going to put a comma here, where I'm adding in another input to the print statement. Okay, and this is going to be the letter F. All right, so press play, and yeah, there we go. We see the letter F. Okay. If anything, You don't have to do this, but it might be more readable if we store this into a named variable. Typically, as software engineers, yeah, readability is a good thing because you're typically pushing code to the manager, and the manager will distribute the code to your coworkers. Um, and typically, the manager would want to be able to skim your code really fast. And to make things arguably more readable, you could put this equation into some named variable. Like, let me just cut this. Right? I'm going to cut it, and it might be more readable if we made a variable called uh, current Fahrenheit. Current Fahrenheit, right, is equal to the equation. So I just pasted that equation there. So if you're curious what's happening, the right side gets evaluated first. So we evaluate the right side and store it to the left, meaning we can print current Fahrenheit here. Okay. So it's the same thing. It's the same thing. It's just arguably more readable. And I guess the why this is might be useful is because your lines could get really long, right? Like let's say we were to try to round this. Right? I think in Python you can just round it by using a function called round. You don't have to do this, but I'm just going to go ahead and round it using a function called round, and I'll put a 2 here. I'll explain why later. And press play. Right, you see how it rounds it to 2 decimal places? Right, but basically, I just use a function called round. So you can look into this later. Python round function. It's, let me see. Okay, I'm trying to find the primary documentation. Okay, this secondary source it'll work. So yeah, it'll tell you what the round function does. It's basically, you give it 2 inputs. In this case, we gave it a decimal number, and then we told it how many to round off to. Right, so that's pretty much what we used there. Okay. So yeah, I hope that makes sense, right? Because if we didn't have a named variable, then it would look kind of ugly, right? Our line would look like this right here, and this is arguably hard to read. So let me just change it back to here. Okay. Any questions about this so far? Okay, no questions. All right. Cool. I hope that gives folks a good head start. If anything, all you really have to do now is access the other values. It's probably going to be harder to do this last part, but I hope folks are able to access things inside of data structure. Right? The last several lines is asking us to get each element inside of the inner list. So it's pretty much saying, hey, go into this daily. Right? The value is going to be a list, and it's going to we're going to have to access things individually. Right? Like first we got to go into daily. Right? This will give us the list, and then you're going to want to access things one at a time. Right? With what we know so far, you'd have to hard code some values like 0, right, and then a 1, and then a 2, right? But that's with what we know so far. In the future, we're going to cover something called loops, by the way, meaning that for most folks, you're probably going to end up with like 7 print statements for these highlighted lines. It's actually possible to do it in one print statement if you do it in a fancy loop. But yeah, we haven't covered loops yet. If you do want to look into it, feel free, right? Always feel free to look ahead in class. But yeah, I hope that makes sense. Okay, I think that's about it I wanted to do for the project. I didn't want to do the whole thing. Just want to give folks a head start. Okay, I'll give it a minute for any questions. You want the Zoom good? Okay. Cool. So yeah, just to conclude things, that's really all I wanted to do today. Oh, let me run this cell. I accidentally clicked into this text cell. So let me run this. Yeah, all I really wanted to do today was, let me go to the weekly schedule. Let's see. Yeah, just pretty much more on dictionaries. Yeah, so we're pretty much done with dictionaries. We covered so much last week and we're ahead of schedule. If anything, we are 45 minutes in, but we have so much more time left. So I'm actually going to stay around for the rest of class. And if anyone has any questions, feel free to let me know. And to make up for so much buffer time, I'm going to record an optional video when I'm at home. The optional video, once again, is going to be covering Python in practice. It's going to be in a different style for software engineers, people going on to computer science, or maybe you're going to be working at a job and the job will ask you to write some tools to help them. Right? It's a Jupyter Notebook is really just for visualizing things and pressing play on very small blocks of code. Right? But another style is writing whole source code and having it interact with actual files. So we'll do that I'll do that in the next video. It's going to be titled Python in Practice. Okay, cool. Thank you all. On Wednesday, we're going to cover strings and printing, and then lesson 8, lab 8, and then next week we're going to spend 2 solid days on HTML. HTML is a website language to make web pages look nice.
Excuse me, Mr. Andrew, did you change the date for the class? Because I thought it was on Thursdays.
Okay, hold up. I'm gonna. Oh, Jim. Jim, I think you're unmuted. Okay, I'm gonna stop recording here and then answer some individual questions.